So we're gonna finish up the proof. We started over here figuring out our relationship between delta and epsilon. And we have let epsilon be greater than, or let epsilon greater than 0 be given. So then we choose our delta to equal epsilon divided by 2, and we figured that out in the first part of the problem. So what we're trying to prove is the definition of a limit, which says if x minus 5 is between 0 and delta, which means if you have a certain distance, around 5 that you're surrounding, that when you take those x values and plug them in, you get y values that surround your limit answer of 10. So if you're a certain distance away from your x, then you will be epsilon distance away from 10. So that's what this sentence is saying. As you pick your deltas that get closer and closer, your epsilons get closer and closer to 10. So as we 0 and a 5, we'll get closer to 10. So what we did is we started with this side of the sentence of the definition. We have if x minus 5 is between 0 and delta, we have that, then we need to show that this is true. So we start here and we say, well, my delta is equal to epsilon divided by 2. We figured that out in the first part of the proof, so I can substitute that in. So that's all I did here was take delta out and put epsilon divided by 2. We figured out that relationship earlier. Then I wanted to break this apart. So instead of having absolute values, I have epsilon divided by 2 and negative epsilon divided by 2. That's just how absolute values work. Then I looked at my goal. My goal for the proof, or for this definition, is if you start here, then you end here. So I'm trying to get x minus 5 to look like this. So in order to make x minus 5 look like this, I have to multiply everything by 2. So multiply by 2, multiply by 2, multiply by 2 gets me here. I'm very close because now these match. So I take my negative epsilon, my positive epsilon, write it as absolute values, and that is where I was supposed to get. So if you can start with this side and you can do a substitution and you can do some algebra to turn it into this, then your limit is true, what you were trying to prove, which this is what we were trying to prove, that the limit equals 10.